Here's a tomato slicer. It's pinned here. It's even got a little spring to keep it open. It's pinned here, and you hold it somewhere in the wide part right here, and you put a tomato here. And then you can slide the knife through. You're holding the tomato without squeezing the juice out. So here's a tomato slicer. I'm going to remove the tomato here. And let's consider this lower half. Over here is a pivot. Okay. And we'll consider the direction in a minute. I am squeezing here. So there's a squeezing force. It's the input force right here. And I'll turn it sideways so we can look at that. That's P. The tomato doesn't want to get squeezed. Let's say that the output force is midway out in the cage over here. So I've got an F, the force of acting on the tomato, and the forces alternate directions. So over here, there's a force down, the reaction force, and we don't care about that force. Next, we need some torque arms. Everything is going to be measured from this pin. So if I'm holding right about here, the distance from the pin, and I'm looking kind of on top, it might not look perfect to you, looks to me to be about, oops, too far, about 7.5 centimeters, somewhere in there, 7.5. And I know that from the angle, let's see if we can see it from on top. Maybe that'll look better. From here to here. Okay, maybe 8 centimeters to the pin. So 8 or 7.5. And now out to the center of the cage to the pin. Let's see here, center of the cage to the pin looks to me to be approximately 14.5 centimeters. Approximately 14.5 centimeters. Okay, clearly again, the pin is going to be the center of torque. This is the input force P, and over here is the output force F. See y'all.